Hello and welcome to m252 Calculus 2 here at Cañada College. My name is Lapuz. In this video we will look at checkpoint 3.13 from section 3.2, the section on trigonometric integrals. Here they want us to apply the reduction formula to this integral where we're integrating secant to the fifth of x dx. A reduction formula is, these are two reduction formulas. There's a lot more that exist. But we take a secant to some power of x, and then we run it through a formula. And the formula is derived by applying something like integration by parts, where you come up with a term plus another term where you have an integral that is hopefully easier to manage. So I suppose we could have done this using integration by parts a few times, but if they have a reduction formula that they're offering, we might as well use that, and that's what we'll do. So clearly we'll be using the one with a secant, and we're going to identify what n is equal to. In this case, n is going to be equal to 5. That's the power of the secant. And then we'll see that when we use this formula for the first time, the power will reduce to the third power, and then we would be integrating secant to the third power instead of secant to the fifth. All right, so following this formula, we have 1 over 5 minus 1 times the integral of secant to the third of x times, this is not an integral. This is just a multiplication. We are multiplying this times tangent of x. And then now we have 5 minus 2 over 5 minus 1 times the integral of secant to the third of x dx. Okay, so we're going to get 1/4 secant to the third of x times tan x plus, and then here we get 3 and 4, 3/4 times the integral of secant to the third of x dx. So we've reduced it, and the power certainly went down, which is great, but it looks like we'll have to use it again. So let's use it again, this time when n is equal to 3. And instead of me having to write everything over again, let me put this in parentheses of what we're going to continue to work on, and then we'll just cascade all the other stuff down when we're finished. So according to the formula again, this is 1 over n. We have a new n is 3. So 3 minus 1. And then we have secant, we subtract 2 from there, as we did before. So this is just the first power, x times tan x. That's the formula for the first part. And then we're going to say add n minus 2 over n minus 1, and then integral of secant of n minus 2, so that's just the first power again, dx. All right, we've successfully reduced again. Let's just rewrite this over. This is 1/2 secant x tan x plus 1/2 again, the integral of secant of x dx. All right, so ideally, this is about as reduced as you can get, and we just have to know what the antiderivative of secant is. Fortunately, there was a formula here that they had established at the beginning of this part of this section, where the secant x is equal to the ln of secant x plus tangent x under an absolute value. So that's what we'll use for that. And here we will have ln of secant x plus tan x, and then we'll just throw the plus c there. All right, so we'll put it all together. because we started all the way up here. So our final answer should be equal to, all this stuff goes down, we have a 1/4 secant cubed x tan x plus, now I have the 3/4 that I would multiply through. I'll start off multiplying the 3/4 here. So 3/4 there is going to be 3/8. And then we have just a secant x tan x. And then now this 3/4 will have to get multiplied by this 1/2. So that's just going to be 3/8 again. And then we have the last term here, ln of the secant of x plus tan x, and then plus c. All right, that's it. I hope that helps.